Hello, ladies and gentlemen. Today is Unit 2, Day 3, Inverse of Functions. Okay, so this is a very short unit. Okay, so after today's lesson, we'll be doing a review and we'll be taking a unit quest. All right, so this is the last new stuff of this unit. Okay, so feel good about that. Now, beginning here, it says definition. This stands for a 1-to-1 function. Okay, so that's what that 1-1 means. So the definition of a 1-to-1 function is a function, so it has no repeating x values, right? That's important about a function, with also no repeating, we'll go y values, and in parentheses, range, right? So we don't have no repeating x values, we're talking about the domain, and we also have no repeating y values, and we're talking about the range. Okay, so that's what it means to be a 1-to-1 function. How can you tell something is a 1-to-1 function? Right? Well, instead of the vertical line test, we give it the horizontal line test. Okay? Not to be confused with the vertical, okay? But what the horizontal line test does is if it hits our function more than once, then it is not 1-to-1. Okay? So that's what it means to do the horizontal line test, right? If it hits our function more than once, then it's not 1-to-1, which means it has repeating y values. And an excellent picture or an excellent example of that would be x squared, right? You got something that goes like this. Okay, you give it the horizontal line test. It's hitting our graph more than once. Okay, so a quadratic is an example of something that is not 1-to-1. Okay? All right, zoom back out here. So, the definition of an inverse function. Well, first let's read what it says there. The inverse of a function will be a function itself if the original is 1-to-1. Okay, so we're talking about the inverse. So really what the horizontal line test does also is it determines whether or not it's 1-to-1, but it also determines whether or not the inverse of our function is a function. Okay, so a lot of words there. All right, so let's just get to the definition and then give a couple examples so you see what I'm talking about. So the definition of an inverse function is a function, okay, that undoes the action of a function. Okay, so the inverse notation, all right, so normally when we talk about functions, they look like this. Okay, the inverse notation looks something like this. Okay, it has a -1 kind of sitting right after that f there. Okay, so that's the notation for inverse function. And then if we were looking at the inverse function, all right, if we're looking at the inverse of a particular function, right, graphically, all right, what it looks like is it's actually just a reflection over the line y equals x. Okay, so if we were to graph a function and then graph its inverse, what you would have is you'd actually have a reflection of that original function over this line right here, y equals x. Okay, and so let's talk about, well, first let me give a couple examples here. Like the best example of an inverse function, okay, so here's the function f of x. Okay, its inverse is actually x squared, okay? And we've seen this before, all right? When you're doing like Pythagorean's theorem, you had something like this, right? In order to solve this, you had to take the square root, okay? What you're doing is you're kind of undoing that original function, right? And so, another excellent example I could show to display this, right, that undoes a function. All right, so let's say I take this guy right here, and I put him in for f of x, right? And so here's our inverse function. I'm going to take this square root of x, and I'm going to put it anywhere you see an x. Okay, so I put it down here. Take away those parentheses, right? And what happens to that square root? Well, it cancels out with that exponent there, right? And you're left with just an x, okay? So it kind of undid, right, our original function, right? Brought it back to just an x, right? And you could do the same thing if I took this x squared and plugged it back in for this guy, all right? You would get the same result. You would just be left with an x. So that's what it means to undo the function, right? It just kind of takes back its actions. Whoop. Okay, so let's look at number 1. It says, will the inverse of this function also be a function? Okay, so how do you know? Well, give it the horizontal line test, right? If it's not 1-to-1, then we know that its inverse is not a function. So will the inverse of this function also be a function? No. How do you know? It fails the horizontal line test. Okay? Now, it says to sketch the inverse of this function, okay? The easiest way I've found it to be done is take some points here, right? So let me set up a x and y chart, right? And this is going to be our original function here, okay? So I'm just going to take some points that kind of fall nice on the line here, okay? See these nice points right there? So I'm going to go -2, 3, -1, 0, or -1, 0, 0, -1, 1, 0, 2, 3. And the easiest way to graph these things, these inverse functions, is to switch your x and y's. Okay? By doing so, now let's graph this guy right here. Okay, so let me put it in a different color. Let me go purple. All right, so I'm going to graph 3, 2, or 3, -2, sorry. 0, 1, or I'm sorry, 0, -1. -1, 0, 0, -1, or 0, 1, sorry, and then 3, 3, 2. And there is our new picture. Our new, that's our inverse function, right? That's the graph of our new function here. Now, what do I mean by this y equals x line? Well, that line always kind of cuts our x and y axes in half. So as you can see, looks nice, well, close to symmetrical, but almost nice and symmetrical on either side of that line. All right, so it kind of flipped over that line, all right, and reflected over this line, y equals x. Now state the domain and range of this. Okay, well, our domain, right, as we go left to right, starts at -1, and goes to infinity. Then our range goes from -infinity to +infinity, right? It's going on forever. Even though it's kind of tipped over, it's still going up, and it's still eventually going to go down. Okay, let's look at example 2. So, will the inverse of the following be a function? Okay, well, we're going to have to say no. How do you know? We have repeating y values. State the inverse of the following function. Okay. So the inverse will go g negative 1x over x. Okay. And so what happens is, again, your x and y values just get flipped. So we go negative 4, 2, negative 2, 5, 1 comma 6, negative 2, 8. And state the domain and range of the inverse. Okay, well, our domain is going to have to be a list, right? So we don't care about the values in between. So our domain now is negative 4, negative 2, 1, and again negative 2, so I'm not going to repeat that. And then our range is 2, 5, 6, and 8. So, to solve for the inverse algebraically, all we're really doing here is we're switching the x and y's, and then we're solving for y. Okay, so in order to find the inverse, that is all we do. All right, so let me show you what I mean. So will the inverse of this function be a function? Well, this is a root. This is a root function, right? So it would look something like this. Okay, if you remember our root function in the beginning, they kind of just curl off to the right. So if we gave the horizontal line test, okay, we would pass, right? It would be okay. So, will the inverse of this be a function? Yes. How do you know? F of x passes the horizontal line test. Okay? Or you could just take this function and do what? Plug it into your calculator and check to see if you have any repeating y values. Okay? So I just know that what this graph looks like, and so that's why I kind of jumped ahead here. But if you don't know what it looks like, okay, plug this in your calculator and find out. All right? So write the inverse of this function. Here's how we do that. So I switch the f of x to the y, because f of x is just a fancy way of saying y. Switch the x and y's, and then solve for y. All right, so I'm going to have to square both sides, right? In order to get rid of that square root, so I get x squared is equal to y minus 5, add 5, and so y is equal to x squared plus 5. So our inverse function is equal to x squared plus 5. And you have to have your answer like this. Okay, let's go down to this one. Will this one be a function? Yes. Okay, what's nice about this particular function right here, this is a linear function, all right? It's got that y equals mx plus b style. Okay, so how do you know? All right, well, g of x would pass the horizontal line test. But also I know that linear functions are one-to-one. But by putting just g of x will pass the horizontal line test would be good enough. Write the equation of the inverse. Whoops, that's a 5. Okay, so I'm going to switch the y's and the x's. Whoops. Then I'm going to solve for y. So I add 3. That's y. I'm going to multiply by its inverse. So 5 over 2. 5 over 2. So my answer is y equals 5 over 2 x plus 10 over 2, which would give me or 15 over 2, right? Whoops. Yeah. Okay, so that would be how we would have to leave it. Okay, or I guess we could leave it like this. Whichever you prefer. Okay, let me move this stuff up here, and we'll finish these problems out. All right, so example 5. Given f of x, okay, or f, given the inverse of f of x, find f of x. All right, let me zoom in here and give myself some room. Okay, so I'm going to bring this over here. So I'm going to switch, again, the x and the y's. So the y will come over here. Well, let me get it written out here first. Okay, I'm going to switch the x and the y's. And then solve for y, so plus 4, x plus 4 is equal to negative 2/3 y multiplied by the inverse. And we get y is equal to negative 3/2 x plus 4. So our original function is actually this guy right there. Okay. So, if you're watching this video, then perhaps you've probably missed class, and so that is why I still posted it anyway, just to give you guys a reference to look at when you're solving these problems, okay? So, for homework, I want you to try them all, except for 11. 11 we'll do in class, okay? Good luck.